Hi everyone, welcome to Distance Learning Day 8. I just wanted to go over a couple of things with you. Now, first of all, we know that technology loves me. Google has been going in and out. So for those of you who actually remembered what I always say, you can always email me if you're having any questions, or you can email Mr. G if you have any questions, or if for some reason you can't post to Google, please make sure you email the assignment when you're done with it, okay? Some of you guys did that between yesterday and today. Good job. Those will count. No late penalties whatsoever. If you're handing in assignments late still, that's a problem, okay? Because those latenesses mean zeros. There's no ifs, ands, or buts. Our rules have not changed since we left. Unless you email us and tell us a legit excuse, they're going to stay as a zero, okay? They're not worth a lot of points anyway, but you guys need to make sure you are doing these assignments so that you are catching up with everyone else in the state. All right, so let's go over a couple of things. First of all, right, here's our board for the week, right? Tuesday is today. You had your tri-quarterly quest due. That's what we are going to go over today with you. Wednesday, office hours, you would be with either myself or Mr. G or both of us, depending on if the children go down. Okay, if they go down for a nap, it'll be both of us. We will have it from 1 to 2:30 or 1 to 3, depending on technology. We'll say probably 1 to 2:30, okay? Thursday is the tri-quarterly exam on Test Wizard, okay? And Friday through Monday, there's no distance learning going over. That is when we are going to be grading everything. We're hoping to get your final grades done by Friday, but we'll see how that goes. All right, so stay tuned for today's lesson on going over the quest. Make sure you have your quests out. They should already be graded, so you can take those out with the grades, take notes. I also posted them on Google Classroom for you so that you can be following along and breaking down the questions like I've told you to before. All right, see you guys soon.
All right, guys, so we're going to do the first question. So the first question, remember what we always talked about. So you look at the question, and it says, while on a field trip to a large lake in New York State, an observer recorded 4 statements about the lake. Which one of these statements is most likely an inference? So remember the difference between an observation and an inference. An observation is something that you can take in using your senses. Something you see, something you smell, okay? Whereas an inference is an idea you come to based on your observations. It's not something you directly see or touch. It's something that you come to. So if we look at the choices, okay, you have the lake was formed by glacial action. Could you have seen that? No. But is there evidence around you that could lead you to that? Yes. So that's why it's the answer. But let's look at the other 3 just quickly. Okay, the water is clear enough to see the bottom of a lake. Obviously, you can see this, so that's an observation. A log is floating in the lake. You can see that, observation. The surface temperature of the lake is 18.5 degrees. You could put a thermometer in that and see it. So B through D are all observations, while A is the inference.
Now, don't forget, guys, when you're doing this, to underline the word inference and write off to the side something that is based on an observation. Okay, that's one of those test-taking skills that we've been working on all year.
Okay, so second question. Okay, you got a whole bunch of stuff here. Remember what we talked about. Don't look at the pictures. Don't look at the big block of text. Find the question first. So if we look at the question's all the way past everything down at the bottom. It says, what is the volume of object D? Object D is this circle right here if you're looking at your test. So you want the volume. It's not there. But what do you have? You have mass and you have density. How do you figure this out? You're going to use the density formula. So, okay, you do the density formula. D equals M over V. You want V. V is at the bottom. We never ever want our answer to be at the bottom. So what are we going to do? We're going to pull it out, just like you do in math. So pull it out, multiply both sides by V. The V cancels out. Whatever you do to one side, you have to do to the other side. So you get V times D equals M, which is not what we wanted. We want the V by itself, but at least it's not on the bottom. It's easy to separate it. Right now it's attached to the D through multiplication. So how do we get rid of it? We do the opposite function, which is division.
Guys, if I see you do the triangle method, it's just not going to be okay by us.
Right? Whatever you do to one side, you do to the other side.
Mr. G, do you agree?
I agree. So it would be M divided by D is going to give you V. If we go back to the question, the mass is 0.8, so that should go where the M is. The D is 0.4, so 0.8 divided by 0.4 gives you an answer of 2. That would be choice B. Question 3. Students calculated the circumference of a globe to be 60 centimeters. The actual circumference of the globe is 63 centimeters. The percent deviation of the student's calculation was, this is a percent error question. You've done this on innumerable number of labs and homeworks and things like that. How do you do percent deviation? You take the accepted value and the observed value, they go on the top, you subtract them, you divide by the accepted value, and you multiply by 100. So it would be 60 minus 63 divided by 63, and your answer comes out to, when you do the math, about 4.8.
Some of you guys are going to get a negative number for this, and that's okay. For our purposes, you're just going to make it positive.
In chem, you do absolute value, you put the absolute signs on the outside and get your answer out. Okay? Question 4, same basic thing. You're going to do the same exact formula that we just did above. Okay? 89 minus 83 divided by 89. You're going to get a decimal answer. You multiply that decimal by 100, and you get an answer of about 6.7%. It's easy, simple math. Okay? Once again, here we have a whole bunch of stuff. What do? We look for the question. There's the question. If the mass of this crystal is 9.5, what's the volume? The exact same thing we did just before. Okay? If you look at it, okay, so we have a mass, we want a volume. What formula do we have that has mass and volume in it? Density. But we don't have density. But if you look right here, spin out, it gives you the density is 3.8. So that would be your D. Your mass would be what they gave you in the question. Okay, you're going to rearrange it just like we did the question before, and so you're going to get V equals mass over density. So it would be 9.5 divided by 3.8, which gives you an answer of right around 2.5.
Remember, guys, 1 milliliter equals 1 centimeter cubed.
Okay, question 6. Okay, now you're solving for mass instead of solving for volume. You're going to use the same exact formula. The D equals M over V. When you rearrange it, the V is going to move over, and so you're going to get V times D equals M. Okay, what's the mass of cube B? They give you the density is 3, the volume is 27, so it would be 27 times 3. 27 times 3 gives you 81 grams, since it's mass. What's the density of cube A? Same thing, you look up, they give you the mass, the volume. This one's easy, you just do mass divided by volume. So 320 grams divided by 64 cubic centimeters, and you get an answer of 5. And the units, neither one's going to cancel out, so you're going to get 5 grams per cubic centimeter, or grams per milliliter, in this case grams per cubic centimeter. Question 8. Assume cube B was broken into many irregularly shaped pieces. Compared to the density of the entire cube, the density of one of the pieces would be. Okay, so what do we say? Density is one of those things that stays the same. It doesn't change. You can have something the size of a tennis court, or you can have something the size of a pebble. And if they're both made of the same object, they both have the same density. So if you have an iron brick and an iron flake, they both have the same density. So B, the whole cube, and B, irregularly shaped pieces are going to have the exact same density. The only thing that can change density is what? If we change the temperature of the substance, which is the next question. If a parcel is just a fancy way of saying chunk of, piece of, okay? If a parcel of air is heated, its density. So if you heat up a substance, what happens to its particles? Do they get closer together? Do they get further apart? Well, if the room gets hot, do you want to be snuggling next to somebody, or do you want to get away from them? You want to get away from them. When it's hot, you try to spread out, like we're all doing, social distancing. Okay, so you're going to spread out. When you spread the particles out, are you as densely packed? No, so your density is going to go down. Okay, and then we're going to do 10 and 11, and then we'll go to the second video. Okay, you guys saw this question on a test, I believe. Okay, so once again, you get a whole bunch of stuff. Okay, this is heating. You're heating up one cup and cooling off another cup. There are different temperatures, and the heat is going to be transferring between them. But let's look at what it says. The rate of temperature change. So this is a rate of change. So when we talk about a rate of change, we have to have two values, a starting value ending value, and a period of time. This formula is on your reference table.
Page 1.
Okay? The rate of temperature change for cup A for the first 10 minutes was approximately what? So if we look at the chart, it all got a little funky on the screen, but it happens, right? At minute 0, cup A starts at 90. When we get to minute 10, cup A is at 77 degrees. So there was a change in value of 90 minus 77. That would give you 13. Okay, so you have a 13-degree change over a period of 10 minutes. So 13 divided by 10 would give you an answer of 1.3 degrees Celsius per minute. And what change in the experiment would increase the heating rate in cup B? Okay, well, the heat has to go across the bar, if you see in the picture. Okay, it has to go from one cup to the other. And the longer that bar is, the more heat's going to get lost to the air. We talked about this when we did specific heat and all those other things. So if the bar wasn't as wide, if it was a shorter path, you'd lose less heat. Okay, guys? All right.